All right, so metals. Metals, there is a lot of different type of metals and uses. We can have steel deck. That's one of the most common metals that you will find when you have a steel deck with concrete on top of it. We can have also a structural metal for framing and for the support of the structure itself. So you see these codes over here are the codes from the CSI. So Division 5 starts with metal, 01 maintenance, 05 common work, 06 schedules, 10 is a structural metal framing, and so on. So I like this type of list because it gives you a reference of all the different type of metals that they have in their list. So you can use that as a checklist and say, hey, do I have this type of metal in my project or not? So we have metal joists, metal deckings, metal fabrications. There's different type of metals. I mean, many types. We could have iron, we could have steel, aluminum, brass, bronze. There's different types.
That's for you.
Yeah.
Do we have this in Blackboard?
Yeah, sure. Yeah.
Yeah. Okay.
Let me check just to make sure, but all my lectures are in Blackboard, so this should be division here in week 3.
Okay.
Module 3 handouts,
Oh, right.
division 5 through 8.
Thank you.
Okay. Then also you have the. Oops, I think yeah. Click the wrong button here. The list with all the CSI codes can also be found under the cost reference. If you go to the cost reference, and then the first item is the CSI master format list. This is very helpful because it gives you the complete list of all the CSI division codes. So it's a good checklist to go by and make sure that you have all your elements in there. So when it comes to structural steel, we have basically 3 types. We have heavy structural steel, the ones that you see around the building to support the structure. We have light gauge structural steel. This is commonly used inside to do the partitions. So it's a small C-shape type of structure that goes inside the walls to support the drywall. Heavy structural steel, we have different types. Wide flange structural steel beams, those are normally identified with the letter W or WF. Structural narrow flame beams, I or S. Miscellaneous or junior beams, M. Channel steel, C. Angle iron, L. Structural tubing is TS, pipe. And then we have plates that you have the metal structure welded to that pipe and supported in some place. The most common operation is to do all the calculations in weight. So you have to either count the pieces or you have to measure the pieces and then figure out what will be the weight of these structures and then buy that by weight. And also figure out what is the size of the crane that you need to pick up these elements and move them on site. The denomination of these structural steel forms, it's important because the beams, channels, and T's, it's a letter, the same letter that I showed before, followed by the depth of that structure and the weight per foot. So if you have a element that says W 12 by 40, it's a wide flange beam with a nominal depth of 12 inches and a weight of 40 pounds per feet. So that's important information because you will see this number on your drawing, then you can measure the length of that element and figure out the weight of that element, right? You will multiply the length by 40, and that tells you how many pounds is that element. An S18 by 70 will be an American Standard beam with a nominal depth of 18, so it's 18 inches, and a weight of 70 pounds per feet. A C1230 will be a standard channel with a nominal depth of 12 inches and a weight of 30 pounds per foot. So that's important, useful information when it comes to identifying metals. Angles are a little bit different. The angles have an L type of shape. So you have two legs on that angle. The designation is the L, followed by the longest leg, and then the length of the other leg, followed by the thickness of the angle. So if you have a L 5 by 3 by a half, that means you have an L-shaped element that has one of the legs is 5 inches, the other one is 3 inches, and the thickness of that metal plate is half an inch. The tubing is TS, followed by the longest cross-sectional axis. So TS 4 by 4 by a half, it's a structural tubing that has a cross-section of 4 by 4 and a wall thickness of 1/2 inch. Pipe, it's called pipe, and you can have it in round format. It gives you the standard diameter and the weight. So a 4-inch standard pipe has a wall thickness of 0.23 and a weight of 10.79 pounds per feet. This information you will find on tables, right? So the pipe will be just called pipe 4-inch, and then that will be a 4-inch diameter pipe. Plates are used as connectors to interconnect different elements or to hold them in place. When you need to bolt a column, you weld that column to a plate and then bolt the plate to the floor. If you do not know exactly what would be the weight of an element, you can figure out by using this number, 490 pounds per cubic feet. So if you're somehow able to find out the weight, the volume of the metal, multiply by 490, and then you get the weight of that element. Let me see if I can show that here. We have an L-shaped channel, an L, and you know this is 3 by 5. This is not working very well. And then this has a 1/4 inch or a 1/2 inch thickness. You can figure out the area of this element will be 1/2 of an inch multiplied by 3 plus 5, right? That will be your cross area. If you multiply that by the length of your structure, then you know what will be the volume in cubic inches. So you translate that to cubic feet, multiply by 490, and you can get the weight of that structure, at least an approximation. Joists are designated by the depth, followed by a letter K, and then the section number. This is kind of a standard format, and then you have to go to tables to figure out the weight of these elements. So for example, we have a 24K3 will be a 24-inch depth K-series joist with a cross-section 3. So then you'll go to tables and figure out the weight. Girders are designated by the depth followed by the series. 24, G5, and 8K will be a 24-inch deep joist girder with 5 bases, and each one of these panels is able to support 8,000 pounds. So this last number over here tells you about the capacity of that girder to support weight. Here are some of the shapes for the different elements. So we have the white flame. It looks something like this, like a big H. So that tells you, the size and then the wall thickness. This is a structural beam. The angle type looks like an L. The C channel, the tubular steel pipe, and then the circular pipe. The plates could be rectangular or could be square. It depends on the application. So it's a different type of formats. That's the structural steel. Then it comes the light gauge structural steel that is used to support walls in commercial applications. These have different thickness from 12 gauge to 18 gauge. The smaller the gauge, the thicker the steel. They normally have punch holes to get electrical cablings going through, and then the finishes are supported by these structures. Here's a picture of an open web joist. You'll see here's some interesting information about joist and metal structures. This is good to go visit because they have a lot of information regarding metal structures. They have technical information. They have publications, a lot of interesting information about the metal structures can be found over there. This video I find very useful. Let's see if it works.
Hello. In this short video, I will introduce you to Open Web Steel Joist and the Steel Joist Institute. Since 1855, Open Web Steel joists have proven their outstanding strength-to-weight ratio, flexible and adaptable design characteristics, their amazing durability, and economic advantages. Open web steel joists are a remarkable and yet relatively simple engineered steel product. Unlike beams or channels, steel joists consist of 5 main components: the top chord, the bottom chord, the end web, bearing seat, and the interior web members.
There you go.
And these components are cut, bent, assembled.
Sorry, I don't know why the volume was not.
Hello. In this short video, I will introduce you to Open Web Steel Joist and the Steel Joist Institute. Since 1855, Open Web Steel joists have proven their outstanding strength-to-weight ratio, flexible and adaptable design characteristics, their amazing durability, and economic advantages. Open web steel joists are a remarkable and yet relatively simple engineered steel product. Unlike beams or channels, steel joists consist of 5 main components: the top chord, the bottom chord, the end web, bearing seat, and the interior web members. And these components are cut, bent, assembled, and welded together to create an engineered product far superior in weight and cost to their monolithic counterparts. Open web steel joists are manufactured using hot rolled or cold formed steel with a maximum yield strength of 50,000 psi. Open web steel joists are often referred to simply as steel joists. We'll use the term steel joists throughout the remainder of this program. In 1928, 5 U.S. steel joist manufacturers came together to standardize their industry. Through the formation of a new association, the Steel Joist Institute, also known as SJI, has developed and established standards for open web steel joist products and the steel joist industry. Since its inception, the Steel Joist Institute has continued to revolutionize its industry by investing thousands of dollars into research, the publishing of load tables and specifications and various other documents, and providing in-depth technical assistance. Furthermore, SJI works closely with major building code bodies, promotes the industry through trade journals, and conducts educational seminars throughout the country. To ensure the standards and quality of its members' products, SJI requires all member companies to have approved design methods for each series of joists. They must also have their joists load tested and pass plant inspections by SJI or third-party inspectors retained by the Institute. This is important because there are various kinds of steel joist products available for different engineering and construction applications. The most basic product alone, a bar joist or short span K-series joist, has over 100 standardized designations across 3 load tables. For design flexibility, long span and deep long span series joists can be manufactured with parallel, single pitched, or double pitched cords, and can also be either underslung or bottom cord bearing. The open web composite steel, or CJ series joists, with parallel cords only, are capable of supporting larger floor or roof loads because a concrete slab is attached to the top cord. This creates composite action between the steel joist and the concrete slab. The shear connection between the concrete and the joist is made by the welding shear studs through the steel deck to the underlying CJ series composite steel joist. Steel joist girders are primary structural members designed to support the concentrated loads applied by the steel joists. Like the joist, there are significant weight and cost advantages for joist girders when compared to solid web wide flange beams. All joists are considered secondary structural products in that they bear on primary structural members such as joist girders, steel columns, and concrete or masonry walls. In typical steel frame construction, joist girders bear on columns. Steel joists are supported by the joist girders. Then the steel deck covers the steel joists and roofing or flooring material is placed for the finished surface. The Steel Joist Institute first published standard specifications and load tables in 1932. Since 1978, SJI regularly produces several publications. The main one is Standard Specifications, load tables and weight tables for steel joist and joist girders. Recently, based on research and testing, SJI has developed standard specifications, weight tables, and bridging tables for composite steel joists. These documents are revised periodically to include the latest changes in the standard specifications, load tables, and weight tables, along with a history outlining the changes from previous editions. The standard specification, a handbook for the product, not only includes the specification load and weight tables, but also includes several other helpful items to quickly aid the specifying professional. The handbook begins with an introduction to K, LH series joist and joist girders. It lists accessories and details slope seat depth requirements and duct opening sizes. Next, there's the standard specification and load tables for K series, LH, and DLH series. And these specifications define load combinations, safety factors, and design equations, camber, material specs, bridging tables, erection stability, and handling requirements. Load tables for uniformly applied loads specified with both ASD and LRFD design methods are also included. The wording above the load tables is very important because it explains the significance of the values in the load table. The load tables list each standard joist designation. The first number is the nominal depth, so 24 means 24 inches from the top of the top cord to the bottom of the bottom cord. The letter or letters denote the joist series. K for K series, LH for long span, and so forth. The last number is a simplified way to note the required loading. To determine the loading, this number must be cross-referenced to the appropriate load table. Note the loads vary based on span, and a 24 K7 at a 40-foot span has a different load-carrying capacity than a 30 K7 at 40 feet. KCS joists follow the K-series joists. KCS joists can be used in cases when the loads are not uniform. Following the K-series information is the LH and DLH series information. The standard specifications for joist girders and joist girder weight tables follows that. The figures in the tables indicate the approximate weight in pounds per foot of the joist girder and not the load. Joist girders also have a different standard designation than a joist. The first number, as with joists, is depth. The letter indicates series, G for joist girder. The next number and letter indicate the number of spaces, and the final number is the load in kips at each load-bearing location. Unfactored loads for ASD design are followed by a K, whereas factored loads for LRFD design are followed by an F.
So that sounds very complicated, but it's not. The important part that I want you to take away from this is that each one of these members has a specific designation, numbers and letters. Then you can go to a cost data book or database such as the one that we have in the book and identify that element. So it will tell you weight and cost, which is the two factors that we care about for the course project and our purposes. A lot of this information has to do with the design of a structure that uses those components. What we care about is the cost and the weight. So it should not be extremely complicated. This second video also about open webs.
Following this information is the Code of Standard Practice for Steel Joist and Joist Girders, which includes the responsibility for design and erection. After that, there is a glossary of terms and appendices explaining joist substitutes, joist top chord extensions, economy tables for K-series joist, an easy-to-use fire resistance assembly ratings chart for all standard durations, and a reprint of the OSHA safety standards for the erection of open web steel joists. In addition to the publications already noted, there are currently 8 maintained technical digests that deal with a broad range of applications. These include roof ponding loads, use of joists and fire-resistive assemblies, the design of joists with uplift loads, vibrations of steel joist and concrete slab floors, handling and erection, welding of joist, using joists and lateral load-resisting frames, and the evaluation of existing joist and joist girders. All of the Steel Joist Institute's publications can be reviewed and ordered at www.steeljoist.org. Why are steel joists the superior choice in a variety of construction applications? For most, there is a definitive economic advantage in using steel joists and joist girders. The cost-to-strength characteristics of steel is well documented. Engineered steel joist products are lighter than comparative monolithic products like beams and channels, and thus cost less. Because steel joists are made from over 90% recycled steel, they have a much lower carbon footprint and consequently are better for the environment as a whole. In fact, 5,400 BTUs of energy is saved for every pound of steel that is recycled. Standardization is another key advantage. When a joist is specified, a 24 K7 for instance, simply the recording of that designation automatically embodies all of the specification and load table requirements for that joist. The joist will carry the load as called for in the load table. It will have a standard 2.5-inch end depth. It will be 24 inches deep and will comply with all of the other requirements of the specifications and the load tables. Additional standards regarding bridging, end anchorage, the allowable deflection, camber, paint, among other items, are also listed as standards in the specifications. These standards must be adhered to in order for a joist to carry a Steel Joist Institute designation. Another key advantage of using steel joist and joist girders is their open web construction. This allows ready passage and concealment of pipes, electric conduits, and ducts of all sizes. By running these materials through the open webs of the joists, savings in floor height are achieved, thereby reducing the overall height and cost of the building. Joists are also easily erected. They are relatively light in weight and can be erected quickly under almost any weather condition. They are permanent structural components, and when properly maintained should not be subject to deterioration in normal environments. In fact, many years ago, while the building was being torn down, the 80-year-old steel joist shop marks were still plainly visible. Flexibility is another advantage. Unlike any other building products, steel joist products are standardized in a wide selection of depths ranging from 8 to 120 inches and spans from 8 to 144 feet with varying loading conditions. With their unitized construction, they eliminate the need for job site assembly, preparations, forming, stripping, or the like. They provide an immediately available working platform as soon as the joists are properly erected, bridged, and welded in place, and the metal deck attached. With this performance record, and an almost unlimited ability of joist manufacturers to design and manufacture these products, steel joists are the building material of choice for schools and libraries, churches and museums, retail stores and malls, industrial and manufacturing buildings, sport complexes, and gymnasiums. For more than 80 years, Steel Joist and the Steel Joist Institute have led the way in providing safe and economical building materials. The Steel Joist Institute has developed a website to help seasoned specifiers to first-time erectors find the latest developments and design aids to make their project as efficient and cost-effective as possible. You can also learn more about our educational seminars and how to attend one. If you desire a one-on-one discussion with a knowledgeable joist designer, feel free to contact SJI or one of our member companies. We are here to help you make all your projects successful with open web steel joist products. Your comments concerning this program are most welcome. Please feel free to write us at the Steel Joist Institute. Thank you.
All right, so I hope that explained a little bit more about the steel joists and how they're made and designed and also labeled. So when we have these elements, we need the structural steel, the cost for that, the fabrication of that element that has a cost associated. Then you have to bring it to the site, that's freight cost, the cost of the shop drawings, assemblies, putting it together on site. You sometimes will need to paint it, so you need to include the cost of that paint and the cost of the labor and equipment to put together this puzzle of structural elements. So you need the labor and crane costs. Here are some of the shapes for those structural elements, and then the weights. We talked a little bit about these already. To connect two elements or more than two elements, you have different techniques. You have plates that can be bolted into both elements to secure that beam to beam, column splice. You have one column on the bottom, one on the top, beam splice. These are bolted, but they can also be welded. So It depends on what the specification calls for. Here's some cost that tells you, an iron worker assembling these structures can put together about 150 to 200 volts per 8-hour day. You will need a compressor, the operator, and it costs about $3.70 per volt. So that gives you a number that you can use to estimate cost of assemblies if you need to. Sorry about that. Oh my God. Sorry. Let me get some water. Some of this information can be found also in the cost books, where they tell you what would be the capacity of a crew, what equipment they have, and how many elements they can install in a given day. All right. Here's some pictures of steel joists. Then we have the metal deck. You saw that in the video. So we have the metal structure to support the metal deck. Then you have a steel deck, and on top of that you have concrete. Most times you will have some sort of reinforcement in that concrete as well. Now it's important to know that from the point of view of assigning the codes and keeping track of the costs, the metal deck and the metal structure goes under Division 5 metals. The concrete and the reinforcement of that concrete goes into Division 3 concrete. Okay? The reinforcement of the concrete does not go into metals. That's considered to be part of concrete.
So like the rebar and stuff like that.
Exactly. Correct. Very good. Here is a picture of a metal deck. It has a specific form. Then we have the handrails. Those are also metal elements that you can find on a project. Here is a picture of a roof frame plan. So you will see these numbers on the side. W, I can't quite read that, but it looks like W14 something. So these numbers are the same indicators that we saw on the video that explains you what type of element that is. So then you can go to the tables and find out what will be the cost for the structure itself and the installation. Different type of steel joists, the different type of anchors that they can have. Any questions about metals? Then we have Division 6, wood, plastics, and composites. Again, we have a long list of items that can be made out of wood. Mostly what we will do is look at the carpentry or structural wood. Depends on the type of building that we have. We may have steel or we may have wood. In the case of our course project, the roof is not made out of steel, it's made out of wood. So you still have trusses and you still have the structural elements, but they are made out of wood rather than steel. So we need to look into that. And then we'll have the carpentry. You may have cabinets and that sort of things that may go into wood. However, if you have wood doors, they will not go into wood. They will go into doors. Okay, so you have to be careful in where you place your costs. You may have plastic fabrications, simulated stone. You can have railings, panelings. Those kind of things can be included into plastics. So, well, wood, pretty much everybody knows. Wood is it's one of the most known and well-used materials for construction. And we can have tons of elements made out of wood. Then we have plastic, which is a synthetic polymer made out of chemicals. So they have different strength, different physical characteristics, colors, and so on that can be used also in construction. And composites are materials that have a combination of other materials to create a element that it's used in construction. In wood, we have wood frames. As I said before, for the roof in our project, we'll have a wood frame roof. So we need to identify all the different elements that support that roof structure. If you go up north, the actual walls of the building are normally made out of wood also, with plywood and sheeting to prevent water intrusion. So here in Florida, we normally have masonry walls, and then we may have the wood structure of the roof. So it depends on where you go, you will find different uses.
Professor, why is that? Just the cost of materials?
I think it has to do a lot with the weather conditions. You know, up north when I was living in Maryland, all the houses were done in wood. Here you have a more solid structure because we have a lot of hurricanes that come in, and that structure needs to be designed to support the wind pressure. And these kind of structures, it's very cheap, easy to install, but they don't support very well, you know, high winds. And in winter also, they require more insulation. You know, the use of insulation over there, it's kind of heavy. Okay, the floor systems, again, we need joists, girders, we need posts, we need to create that structure, and some of those elements will be counted, some of those elements will be linear components. You know, it depends on what you're looking for. And again, there is the assembly cost data that gives you a cost per square feet of the flooring system, including all of these components. Okay, and then there is the unit cost data that gives you cost data for each one of those components separate. So it depends on what type of estimate you're doing and what level of detail you're doing. You may want to look into one or the other. Okay. Heavy timber construction, that's structural wood used for the beams and the columns. They could also be used as decoration items to provide a rustic look. So you need to see where these are included. Sometimes you have structural wood that comes pre-assembled from the factory, is glued and molded and nailed together, so you just come in and install it. So you have to take that into consideration. We'll see some of these structures in the roof of our project. You may need to have some treatment for that wood, and that costs extra. Fire retardant or termite protection, moisture resistant, all of those items you need to be careful with because they can add cost to your project. And if you don't really read carefully the specifications, you may have to pay it out of your pocket because you forgot to include it in your estimate. You'll have steel plates also. Whenever the wood meets masonry or concrete, there is normally used a seal plate as a base to separate the two. So, you know, remember to include those seal plates. They go like here. We have a masonry wall, and then we have a joist. So there will be a seal plate right on top of the wall, and then on top of it comes the joist and the rest of the structure. girders to support the structure. Here's a picture of them. Also, you may have to have openings in the wood structure. So if you have studs that are supporting the top and the bottom structure, and you need to make an opening, those studs get cut to the size. So you still need to count them because you need the whole material, even though it looks just a piece of it is required. And also you need to consider that at the edges of this opening, they're normally double support. So you need to have two studs on the end of the openings rather than the regular one stud. So those things you need to take into consideration. Sorry? Somebody else. Here's another measurement of wood is the 1,000 feet board measure, MFBM. So you take the thickness of the lumber, multiply by the width, divided by 12, because this will be in inches, and that gives you feet. Multiply by the number of pieces times the length will give you a volume. So that's in 1,000 feet board measured. It's a number that may appear somewhere, as you work with wood. One board foot is equal to the volume of a piece of wood that is 1 inch thick. Okay, so the thickness will be 1 inch. And it has 1 square feet of area. So that's one footboard. In walls, we have studs that are counted items. You count how many studs you have in your structure. Then again, there are some rules of construction. You need 2 extra studs at the corners, at the intersections, 2 for door openings and windows openings. So, you may have also extra studs on top and bottom, depending on the size of the window and where does it fit within the overall structure. You have headers, those are counted items. You have blocking, which is linear components. Sheeting is normally a area measured. Then nails and those kind of things are estimated by weight and estimated by experience. Also, there are some tables that tell you how many nails you need to put together a wall. Different type of nails, here is a table that shows, for carpentry uses, how many nails you will need to cover a certain area. I don't think anyone will get down to that level of detail. That is when you're doing that type of trade in construction, you do want to have all your costs estimated to that level of detail. Normally, if you're just getting a budgetary number or you want to have an idea of how much it will cost, you don't get down to that level of detail. You use a value per square feet and you move on. Otherwise, you'll spend a considerable amount of time doing the estimate if you need to go down to the level of how much glue you're using and how many nails. Here's some examples of the different wall openings. So depending on where the opening is, you will need more or less reinforcement on the sides. And this is what I was talking about. You need to count these studs completely, even though you only have a portion of it, because you need to cut the stud to get the actual size. Here's a typical wall section. You have some sheeting, you have siding, you have the insulation, and then you have the interior board, the gypsum board. On top of that, then goes paint or whatever. The floor structure, you have the joist, and you have some some support, and then you have the final floor with the carpet or whatever it's going to be. So, you need to identify those items, count for them, and estimate their cost. Here, very, very similar to the metal structures, we have wood structures that have pretty much the same type of shape and uses. So it's just a matter of getting the cost of those items. Soffit is a sheet good. The soffit is the one that goes over here to cover the exterior of those sections that go beyond the wall. Then you may have trim, that would be counted items, shelvings are counted items, panelings, cabinets are counted items. And oftentimes you won't have a good source of cost for the exact type of panels or shelves that you need. So you have to go into Home Depot, Lowe's, those kind of websites, and figure out what type of shelving you're using, what type of cabinets you need, and then use the information on the cost books to figure out the installation cost. Then we have thermal and moisture protection. This prevents water and heat to go inside the structure. So again, there is a large number of items that can be included in this area. We will have thermal protection and insulation on the walls, on the roof. We'll have thermal protection along the water protection for the foundations. You will have a small plastic that protects the foundations against water penetration, and also the slab on grade. These elements basically seal the building to prevent water and heat inside the building. So they're normally they're measured by area. Here's an example where you have two components. So you have this element, this plastic, or this could be asphaltic over felt to prevent water from going inside the building, and then you put the rest of the structure around it. Normally, these are separated by the materials and also the capacity for insulation. So you have an R value that tells you what type of resistance it presents to heat. I don't see that information here anywhere. Or maybe later on. Then there is damp proofing to prevent water coming inside the building. There are different methods to prevent water to come in. And then you have this bituminous material. It's very typical of roofs where you see somebody coming with a torch and an asphalt liquid type, putting it on top to seal the roof to prevent water coming in. And residentials, we normally see the shingles, or we see the tiles that gives you some protection from the roof. Here we go. The insulation is typically per square feet. It's an area item. You specify the R value, which is the protection it gives you against heat coming in. The higher the R value, the higher protection you will have, and also the higher cost. So you want to identify what type of different insulation types you have. Normally they come in in rolls, or it could come in bags, depending on the type of insulation they're requesting. In some cases, when you need to maintain shape, they can be a rigid type of insulation that is cut in and then put into place. Some of these insulators can come also with vapor barriers to prevent moisture to get inside the building. The vapor barrier by itself can be estimated by square feet. It could have different type of thickness, so you will basically separate them by thickness and materials. Here's a picture of a vapor barrier, and it tells you this comes in rolls. I guess 15 by 50 feet, 10 of those. No, I'm sorry, it's a vapor block 10, which means it's a 10 millimeter thickness vapor barrier, and then the size will be 15 by 50. That's how that roll will come in. When you install vapor barriers, you need to consider an overlap. So there is an extra material that you need to take into consideration to cover for the overlap. Roofing, again, insulation, you have the built-up or the different type of roofing that you must have. And this includes the weather and thermal protection of that roofing. The structure of the roofing itself will go into metals or into wood. Thermal and moisture protection examples, look at the footings, look at slab on grade, look at the wall finishes, roof structures, the stairs. All of those elements will have some note that will reference thermal and moisture requirements for your project. Here is an example of a drawing that will bring in a note for vapor barrier. Here it says ground floor slab shall consist of a 4-inch, unless noted otherwise, slab on grade placed over a 10 mil vapor barrier. So then you need to add in your estimate that vapor barrier and look for that measured by area. Here's an example where we have we use on-screen takeoff to measure the area that we need and then estimate how much vapor barrier we need. So here's the area. We create a condition, area condition, start clicking on the corners. We come up with the area, and then we will add. Actually, this is the first shot that you will see for that software on the WinNest that you have in your book. This gives you a list of items, okay, per division. So we have general conditions, site work, concrete, thermal and moisture protection will be in division 7. So you highlight that one. When you highlight the division, then it brings you to a detailed menu. So we're looking for waterproof and then vapor retardants. So within that, it gives you a list of different type of protection that you may have: 4 mil, 6 mil, 8 mil, 10 mil. So these specifications calls for a 10 mil vapor barrier. So we select that one. Okay, we include that over here, and then click Add Item. This one has a cost of $12 per square feet. So basically what you will do is then multiply the 1,680 square feet that you estimated with WinNest times 0.12 cents, and that gives you your cost for vapor protection. So again, it's very, very simple. The WinNest will give you a lot of information, and we'll talk about that when we start working with the software. It has a lot of columns in there. Basically, it has a unit cost, and it has a labor cost, it has a material cost, cost for equipment, and so on. But at the end, what you really want to do is multiply the unit cost times the area that you have, and that will give you the total cost. In this case, the software already includes a 5% waste factor. So when you enter that you need 1,680 square feet, it includes a waste factor, so it goes up to 1,764. So you can see that it's already included in the WINEST a factor for waste. Otherwise, you will have to include that yourself. Okay, so that's the example in terms of the area. Now, if you want to estimate also, how many rolls are you using from this to cover this area, then you need to start doing a more detailed calculation where you consider the overlapping of the rolls. So then you will take the area that you need to cover and divide that by the effective area of the roll that you're using. Okay? The effective area of the roll that you're using is the area of the roll minus the area that you're using for the overlap. Okay? So that will give you the effective area of that roll. So you divide the whole area that you need to cover by that effective area, and that tells you how many rolls you would need to complete the installation. So here in this example, the area of the roll, I believe, is 50 by 15, right? As we saw in the sheet. So it has a ½ inch on the side and ½ inch at the end, half of a feet, 6 inches on the side and 6 inches on the end. So from that area of the roll, you take out the 2 sections for the overlapping, and now the effective area is 14.5 by 49.5. That's 717.75 square feet. So if you divide the area that you need to cover, 16,800, by this effective area for each roll, it gives you how many rolls you need to cover that area. So 23.4 is approximately 24. You can't go and buy 23.4 rolls. You buy 24 rolls. And that way you can estimate how many rolls you need and multiply by the unit cost of those rolls. So then you get the price or the cost that you're spending in insulation. Okay? So the two numbers are similar, but the way to find them is different. You follow what I'm saying? You are using on one side a cost per square feet and adding a waste factor, and on the other one you're actually estimating how many rolls you need and then multiplying that number by the cost of each roll that we have here. So here in this material, this vapor barrier from this manufacturer online, it tells you that a 15 by 50 roll will cost you 138.5, right? So you estimate how many rolls you need, multiply by that number, and then you get your cost for materials, which is a little bit different from taking a cost per square feet and multiply by the area that you have and adding a waste factor. But both numbers should be quite close. Okay? Is that clear? Okay, very good. Here, this just talks about another option for different costs because the two costs found in the example were different. Then we have openings. Openings are windows, doors, frames, hardware, and all that items that are related to entry and exit the building. So we may have storefronts, we may have regular doors, panels, frames, traffic doors, different types of doors and windows. Skylights are also included in here. Anything that you have an opening to that you need to put something on it, that will be considered openings. Normally we have a schedule on the drawings that gives us the identification of the type of door or the type of window that you need. It gives you a description of what it is, the materials, the manufacturer, the model number in many cases. And all of these are, of course, counted items. An important check to do is that you take your schedule and then you go on the drawings and check that all the doors and windows that you have on the schedule are actually reflected on the plan drawings. So you do that double check. You may have to include hardware. Sometimes that's sold separate, or you need to have special hardware. For example, right now we are doing a lab at the engineering center. So the door is one thing, but the access system is using swipe cards. So then the procedure to entry and the hardware that you need is different than if you have just a key. So that has to be taken into consideration when you're doing your estimate. Here you can see different types of windows that are available, and of course each one of those will have different materials, different costs, different installation costs. So you need to take into consideration all of those elements. Any questions?